Hey guys, it's Miss Johnson and I'm here to bring you our last notes video for Unit 2. Today we're going to be talking about how to decide what method we use to solve a system. The two algebraic methods that we've learned are now solving by substitution and solving by elimination. And both methods work just fine for any single system, but it's convenient to use the methods at certain times. So we're going to talk about when we would use substitution and when we would use elimination and how we see those things when we look at a system. So let's first talk about how we would decide when to use substitution. Now for substitution, if we've got a variable that's already solved, if we've got a y equals, oops, I'm in yellow here, y equals or x equals whatever, x equals something or y equals something, then we're going to use substitution. We've already got a variable alone, so it's easy, really easy to just stick that phrase in for the other variable and the other equation, and then we're good. Also, if you have equations in slope-intercept form, remember slope-intercept form is y equals mx plus b. Or if you've got a variable that's easily solved for, it may not be alone yet, but with just one simple quick step, you can get that variable alone, then I would use substitution. So basically here we're looking for a variable that's alone on one side of the equal sign. Okay, that's when we would use substitution. Now for elimination, if I were going to use elimination, then I'm looking for equations in standard form. That's that ax plus by equals c. So I want both of my equations to be in this form. I'd have the x's and y's together on one side of the equal sign, constants on the other. It's really nice when you have opposite signs, like if you have a negative x and a positive x. It's also really convenient, or even a negative 4x and a positive 4x. Those are opposite signs there. Those are just examples. It's also really convenient if you have like a positive 4x and a positive 4x, because it's really easy to make one of those negative. Okay, example here. So basically we want the variables and the equal sign lined up here. Okay, so that's when we would use elimination. So let's just do some examples and talk about why we might choose a different method. In number 1, I take a look at my system. It's got 3x minus 5y is equal to 7, and 2x plus 5y is equal to 13. So I notice right away that I've got the x terms lined up, the y terms lined up, the equal signs lined up, constants lined up. Both of these equations are in standard form, that one and that one. Okay, since both of them are in standard form, I'm going to use elimination. So I also notice that the y's already have opposite coefficients. That negative 5 and positive 5, that's an opposite coefficient there. Okay, opposite coefficient. So when I look at those two, I'm already set to add them together. I'm ready to take care of that already. I don't have to multiply by anything to give myself opposite coefficients because I already have it. So when I add these two together, I end up with 3x plus 2x, which is 5x. And then I get the negative 5y and 5y cancels out because that makes 0, so it goes away. And on the other side, 7 and 13 is 20. So I've got 5x equals 20. I divide both sides by 5, and I've got x is equal to 4. Then I can plug that back in and get the y. I'll just use the top equation. Doesn't matter, both will work. Minus 5 times y is equal to 7. That gives me 12 minus 5 times y equals 7. Subtract the 12. Negative 5y equals negative 5. 7 minus 12 is negative 5. And divide by the negative 5. So I get y is equal to 1. Now remember, we always write our solution as an ordered pair. X comes first and then y second. So 4 comma 1. All right, so let's take a look at number 2. In number 2, we have 5x plus 3y is equal to 3. And we also have y is equal to 2x minus 10. Now right away I notice that I've got this down here. okay? Y equals, that's a variable alone. That right there is going to tell me that I should use substitution. That substitution is going to be really convenient and easy for me to use. So I take this 2x minus 10 and I plug it in for y in the first equation. That gives me 5x plus 3 times 2x minus 10 is equal to 3. So distribute that 3, you've got 5x plus 6x minus 30 is equal to 3. And then 5x plus 6x is 11x. I can put my x terms together and add the 30. I get 11x is equal to 33. Almost there. X equals 3. So there's my x variable. Now I plug that back in. I'm going to use the bottom one because I've already got y alone. So I'd have y is equal to 2 times 3 minus 10. That's y equals 6 minus 10, or y equals negative 4. And again, I write my solution as an ordered pair. X comes first, so 3 comma negative 4, and that is my solution. Let's try number 3. When I take a look at number 3, the top equation has y plus 3x is equal to 24. The bottom equation, 5x minus y, is equal to 8. Now, the equal signs and the constants are lined up, which is great. But in this top equation, my y term and my x term have been flipped. I can really easily fix that. If I flip that 3x and that 5y back, I'd have 3x plus y, not 5y, just y. 3x plus y is equal to 24. The bottom equation's already in standard form, so I'm going to leave that the same. And now I'm set up really nicely to use elimination. X terms lined up, Y terms lined up, constants, equal signs, all of that. And bonus, the Y terms have opposite coefficients, positive 1 and negative 1, so I don't have to multiply by anything. This is already ready to go. So I'm going to add this together. I end up with 3x plus 5x, which is 8x. The Y terms drop out. 24 plus 8 is 32. And I divide by 8, I get x equals 4. Plugging that back into either original equation, I'll just use the top one, y plus 3 times 4 equals 24. That's y plus 12 equals 24. Subtract the 12, and I get y is equal to 12. So a solution here would be 4 comma 12. Okay. Now let's take a look at number 4. This will be our last one for our notes video today. In number 4, I've got 5x plus 3y is equal to 16 and 3x minus 5y is equal to negative 4. All right, both equations are in standard form. X is lined up, y is lined up, equal signs lined up, constants lined up. They're ready for that. But both equations have, or neither of the equations have opposite coefficients. They don't even have the same number. So I'm going to have to multiply both of these equations here, okay? So I'm just going to eliminate the y terms because I notice that one y term is positive and one y term is negative already. So I don't need to worry about my signs because they're already opposite signs. I just need to make the numbers the same. So I'm going to multiply this top one by 5 and this bottom one by 3 because that's going to give me 15y and negative 15y. But again, this needs to go across all parts of the equation. So that's 25x plus 15y is equal to 80. 16 times 5 is 80. And then 9x minus 15y is equal to negative 12. All right, so here we go. 25 and 9 gives me 34x. 15 and negative 15 is going to go away, so I'm done with that. And 80 minus 12 is 68. Divide both sides by 34, and I end up with x is equal to 2. Now I can plug that back in and get my y variable. Go back to the original equations just in case you somehow made a mistake here. You always want to use an original one. So 5 times 2 plus 3y is equal to 16. That's 10 plus 3y equals 16. Subtract the 10. 3y equals 6 and divide by 3. So I end up with y is equal to 2. So my solution here, when I put it all together, would be x first, which is 2, then y, which is also 2. 2. All right, that's going to go ahead and conclude our video for today. Thanks for watching. Don't forget to go back to Schoology and take the little Schoology quiz. Have a great night, and I'll see you tomorrow.